Alright guys, welcome back to the channel and welcome back to another episode of our RPG series. In this one, we're going to try to animate the enemy as he moves around. That's what we're going to be trying to do. So yeah, in this one, we're going to be trying to animate this guy. And then we're also going to make him chase the player when he sees the player. Okay, so it's going to be just those two. Those are the two little mechanics we're going to. Well, one is a mechanic and one is just animating. So let's get into it. What we're going to do is we're going to go into characters, into the enemies, and then into the enemy behavior script. You're going to open that up with Visual Studio. So this is what we currently have. We've got patrol, if enemy is of ground, and then we've got the patrol logic there, and then we've got the check for player here, which is empty. We are going to create, first of all, we're going to start with few variables at the top here. So we're going to come here and say we want a private, a boolean player found be equal to false. We're going to make it equal to false. Then here where we're doing patrol is so if player is grounded, then we're going to say let's not say if again, let's just say right here, and is player and player found. I'm gonna put an exclamation mark right before it to negate it. Okay, sorry about that. Oh my goodness. And not player found. So if that's the enemy type and the player has not been found, you patrol. Else you anyway, we'll get into that later, but for now that's what we're going to do. That's what we're going to do. In fact, because of this I don't want to do that. Let's put it here actually, because I've thought about it. So if not player found, let's do it like that, and then we're going to say patrol. So let's remove it from here, because when we add the patcher behavior, it might conflict there. Now inside our patrol, we're going to do one thing here. We're going to say, so this is our patrol logic here. This is our patrol logic here. So we're going to say, we're going to add some stuff here. We're going to say if patrol point dot, okay, so that's okay. Let me see. No, wrong. We're going to say if the current wait time. So we want to be able to wait a few seconds before at each point. Okay, so we want him to move to a point, wait a few seconds, like he's patrolling it and looking around, not just keep moving. So we're going to do if current wait time is greater than 0. So that's what we're trying to do here. We're trying to make sure that every time he waits for a certain amount of time at each point. So let's create a float up here and call it public. Actually, let's make it a serialized field, because we're not going to use it anywhere else. So serialized field float current wait time. Current wait time. That's what we're going to put it as. We're going to initialize it as Let's put it at 0 for initialization. So I'm sorry if you can hear that. It's beginning to rain here, so we might be hearing some thunder and stuff. But so we're going to say if current wait time is greater than 0, what are we going to do? We're going to say current wait time will be minus equal to time dot delta time. Okay, we're going to do that. So else we're going to get into our patrol logic here. So we'll do that. Else, what we're going to say, are we adding anything else? We've got the if that vector 3, and the if the distance is less than that, then we're going to right here, we're going now to say once we've reached a point, the first thing that we're going to say is current wait time, we shall equal it to random dot range, and then we want to give it some options to choose from. So it's going to choose from two variables that we're going to create in a minute. So it's going to choose from wait time minimum, which is min, and wait time max, which is maximum amount of time that we're telling it to wait. So let's go up there and create those two variables. So we're going to say serialize field float wait time min, which we're going to initialize at 3 seconds. So we want it to wait for 3 seconds, 3 to 6 seconds at each point. So it will be a random, it will not be, so you cannot just master it. You know how if you're playing a game, you master that, okay, this enemy waits for this long at this point. So it will be very random, between 3 to 6 seconds, like that. So you can what you can actually do is change that number to whatever number you want. I'm just using those two because I prefer that to give the player some time to actually put up some stealth kills. We haven't yet started that, but yeah, so we're going to do that. Then what we are now going to do is we're going to now have to animate it. So in order for us to animate it, let's do this. Let's add an animator here at the top here. Let's say serialize field animator. Animator. I don't know if we already added it. Did we add it? No, we didn't. That's fine. So in the start here, let's now say animator. Since this is sitting on the parent, we're going to get component in children animator. Now at the point when it's less than or equal to, that means we've reached a point, we've reached a patrol point. What we're going to say here is the animator dot set float. So remember, we've got the vertical float that we use for animating our character. If you remember, we were setting the vertical float to our horizontal and vertical inputs, but since this is an AI, there is no input here. So we're just going to set the vertical float property in the animator to 0. That means he goes back to the idling position when he has reached a point. If he hasn't reached a point, before we move, we're gonna go and say animator dot set float. We're going to set float of the vertical, vertical, then we're going to set it to we need to set it to, so we know that 0.5 is working, so we want him to be able to so we set to 0.5 f, so that he is walking, not running. But you will see what we'll do in a bit when it comes to the part where he has to chase the player. Then for the enemy patrol speed, we'll have to change it as well. But for right now, this should work. We should now be able to have our player, our enemy, animated. So let me see here. If we hit play, our animator should pick itself. So you can see there he is. He's animated. He reaches a certain point. He stops. But when he stops, it's not setting him it to 0. So he keeps walking. Alright, let's fix that. Let's fix that. So what we've said is, once it's there, the animator to set value of the vertical, we're setting it to 0. Okay, here we forgot to put our else, because it's still running through everything. But we're saying if distance is that, it should only do that, and only when it's not that should it do this. But right now it's doing everything. Then in here, let's also change one thing. Let's say enemy behavior dot patrol speed. We're going to make it equal to 2.5 f, because we want it to be half of what it is, so that when it's all the way through, it's you can see right now when he was walking, he was actually gliding, but we don't want that. We want him to be able to just be walking normally. So he stops, as you can see, and then he continues again, and then he stops. So at this point, you can do even more. You can make him look around, like turn around and do all that, but we're not going to do that in this series. But you can do it. It's just it's simple. It's just turning him around, or you can even use different animations. So you can set up different idle animations for when he's there, and then you can play a random idle animation, which you can play a random idle animation. So you can see he's stopping. Then we are saying that at that point he's looking around at that point, because patrol's there, he stops there for a random amount of time, and then it goes on to the next point. Okay, that's all well and good. I just have one problem. This guy looks like he's floating. Let's just fix that. Come over to the dummy, and you can see why it looks like it's floating. What we can see is, let's go into this view here, is that look at the floor. Let me do this. Let's actually do this. Let's come to the dummy. You can see that the collider, he's way inside the collider. So what we're going to do is to come down to the character controller itself. We will move it up on the Y to somewhere there, so that his feet are touching the ground. And then we can see that up there it's actually quite big, so let's change that to 1.8, and then move it down a bit more, somewhere there. That's perfect. That's perfect. So you can just click that to go back into the ISO mode. So this is the perspective. Okay, let's get back here and see how he's looking. He should no longer be gliding in the air, but actually, yeah, he's walking on the ground now. There he goes. He walks to there, he stops. So he's more like patrolling this area. Let's now change one other thing. So if you come to his enemy behavior, so this guy, the ground enemy behavior, you can see that the vision range is 50. I think that's too much. Let's make that 10. Let's make that 10. Then what we're going to do now is to come into our check for player function. So it's also going to be quite simple. So now let's say vector 3. I'm going to say vector 3 npc forward for npc forward dir for direction is going to be equal to the transform dot forward where our script is seated. Well and good. Then we're going to say now vector 3 then to player. My goodness, if I can type. To player is going to be equal to the player dot position minus the transform dot position. All right, then we're going to now come here and say float angle is going to be equal to vector 3 dot angle of a npc forward and to player. Then we're going to now say so what we're going to say now here is we need let me just put a comment and say set chase speed for when player is detected. So what we're going to say here now is float chase speed is going to be equal to 1f. Now this is not really the chase speed because that is the patrol speed, but this is more of the float value that we need to pass. Actually, let's change that. Let's say chase value. Let's say chase animator value. So let's say chase anim value. This will be equal to 1 because we want it now to play the run animation. So we need to pass that in. Then we're going to now do another ray cast. So we're going to say ray cast. Come on, if I can type. Ray cast hit, which we're going to call hit, like that. Then we're going to say if, oh my goodness, I can't type today. If physics dot raycast, then npc forward direction, and then comma to player dot normalize, and then out hit, and then we're going to now give it the enemy behavior dot our vision range. So that's how much that's how far we want it to be able to, this raycast to be able to go. So that's what we're calling as the site. What we're going to say is first of all, we're going to debug dot draw ray. Then we're gonna say we're gonna say npc for direction, comma to player dot normalized, and then multiplied by enemy behavior dot vision range And then the color, we're gonna say color dot, say color green. Then we're going to say it should stay on the screen for 3 seconds. You can save that. So what I'm thinking we do here is that let's first see how this behavior is looking in the game. So let's hit play. Let's so we're not getting a cast. Okay, we might need to fix that. Okay, we might need to fix this. Why aren't we getting a ray cast here? Alright, let's just finish it and then we'll debug it properly. So let's say if hit.collider, not if hit.collider dot compare tag, and then I'm gonna say the tag is player, then actually I think once we hit a player, that's when we should debug. That is when we should, now let's debug it. But let's debug it as red lines. But then if you hit the player, it should debug as green lines. So once the player has been found, we are going to change here and say player found is equal to true. Now once player found is equal to true, we're going to come here and say if enemy behavior dot enemy type is equal to enemy, so enemy type dot ground, because only grounded enemies can chase. For the other enemies, it's just going to be to fire arrows. So we're gonna say ensure enemy is always facing player. So what we're going to say is quaternion. If you remember, we used it in the movement. We're going to say target rotation, which is going to be equal to quaternion dot look rotation, and then we're going to say negate to player, and then we're going to say transform dot rotation is going to be equal to quaternion dot slurp. What are we slurping between the transform dot rotation of our current script and then the target rotation, and then we're gonna say time dot delta time, and then multiplied by 5.0 f. This should be inside the bracket, not outside the bracket, like that. Then we're now going to say enemy behavior dot patrol speed changes here to be equal to 5f. So we are making him move faster because he's actually running. Then we are going to now say move towards player, and we're going to say vector 3 move vector 3 move direction is going to be equal to player dot normalized multiplied by enemy behavior dot throw speed. Okay, enemy behavior dot throw speed. Then we're going to say move direction dot y. We'll negate it on the y. We do not want any movement on the y. Then we're now going to say animator dot set float vertical. What are we going to set it to? We're going to set it to the chase anim value, and then we're now going to say the character controller dot move, the move direction multiplied by time dot time. Okay, so that's the chasing behavior right there, provided our raycast doesn't fail. So let's just look at it again. So we set our vector 3 NPC direction, and then to player itself, the angle we set it as well. Then the angle will come in handy if we're going to do some turning animations. That angle come in handy. I'm just putting it there for now. Then the raycast hit, and then we say if physics the raycast, and then fine, let's do it like this. Let's change this because it doesn't seem to want to work. Let's say transform dot position, and then to player dot position enemy hit in the vision range, and to debug dot draw line. I'm going to bring this down here as well. There we go. So it will always be coming from the object where this script is seated until we can either decide to make it come from the eyes of the player or something like that. But for now, if I saved everything, let's look at this in action. Okay, so we can see that we are having that happen. That's cool. That's cool. Let's come to here, and instead of negating it, let's leave it as to player. And then we don't want him to chase us immediately. I want you guys to look at this. So we're going to get our player, in my case MC, move him backwards so that these guys' rays are not able to hit. And we can see that they are not able to hit currently. So he's patrolling. As soon as he hits, you can see he's chasing us now. And you can see from the left side our raycast showing there. As soon as it hits, he's chasing us. So now what we're going to do in the next one is to make it that when he gets to a certain range, he hits us. So we do not want him to get, like, if I'm standing here, let me just show you guys. If I am standing still, let's actually move forward so that he sees us. We don't want him to come up and run up on us like that. All right, we want him to start to reach up to somewhere there in acceptable distance. Once he reaches that acceptable distance, he must attack. He shouldn't be running up to us like that, because you can see that actually there he goes back to being normal and chasing us again, and then hopefully we'll make him never catch us. Right, there we go. We've left him for days. He's coming. Okay, so that's what we're going to do next. We're going to make him reach just a certain acceptable radius before he performs an attack. So that's the logic for him chasing us around. you can see that it's coming up. So if you enjoyed this episode, or leave a like. Last I checked, we've hit 100 at the time of recording. So we hit 100 subs at the time of recording. That's, I can't say thanks enough. That's a lot, and I appreciate everybody who's enjoyed the series so much that they've decided to subscribe. I am working on the Unreal Engine devlog. It will be coming out as well soon. I just don't want to just keep flashing out devlogs unless we've really made some serious progress. So currently the progress that we've made in the game is quite small, but once significant progress is made, I'll bring that to you guys as well. And for those guys who are primarily Unreal Engine developers and want to have this series, you can let me know. Then I can also do one for Unreal Engine. It's actually much easier with Unreal Engine than with Unity, because for Unity we have to do the whole character controller from scratch, whereas for Unreal Engine we already get the third-person template and can just use it from there. But for the Unity devs, we are getting closer and closer to doing some other interesting stuff. So again, if you're new and it's your first time hearing this voice, and you've enjoyed the series, the episode, you can watch all the others from 1 up to the current one, so that you can follow along and create your game. You can make any changes that you want. You can also join our Discord link to share your game progress, to share your challenges, so that we can all sort them out together. Again, 100 subscribers is great. I appreciate it so much. And yeah, I probably will maybe do a texture pack giveaway. So we'll be having some magic mechanics. So I'm gonna buy 2 texture packs. One for myself, for me to use in the game, and one will be for one of you guys. So you can just comment down below if you want to have that texture pack, and then I'll give it to you probably before the next video. Alright, thank you all for watching. If you enjoyed this, leave a like, comment, subscribe, and I'll see you all in the next one.